So this is a vectors question, and it asks a number of things about some vectors, including the angle between two vectors, but it starts by asking to find the vector AB where the position vectors of A and B are given. So to find the vector joining 2 points AB, you would subtract OB minus OA. So the position vector of B minus the position vector of A. So the position vector of B is given 3i plus 4j, so we can write that in vector notation or matrix notation like this: 3, 4, 1 minus OA 2, 6 minus 1, and that gives us 3 minus 2 is 1, negative 2, 2. So that is our vector AB. So it's I minus 2j plus 2k. So we can write that, if you want, like that. So we can say it's I minus 2j plus 2k. The question then goes on to ask for the vector equation for the line L1, which is the vector that passes through A and B. So if you think of A and B as being these 2 points, we just found the vector AB. So we found that vector, the direction from A to B. But to find the actual line L1, we would need to say something like the position vector of all points on the line equal the position vector of a point, let it be A, plus some constant, or some parameter rather, not a constant, multiplied by the vector AB, which is the direction of the vector. So your vector would end up looking like 2, 6 minus 1 plus lambda into the vector AB that we just found, 1 minus 2, 2. And we can write the final answer. We can leave it like that, I guess. The vector equation of the line, we can simply leave it like that. That's, I think, good enough. The question goes on to talk about another line, L2. And we're given the direction of L2. And we're asked for the angle between L1 and L2. So let's first find the direction of L2. So L2 has a direction that's parallel to I plus k. So that would be something like, if we wanted to write the equation for our second line, it would be R2 equals a point that it passes through. We're told it passes through the origin, so that's going to be 0, 0, 0, plus another parameter, let's call it mu this time, times the direction. It says I plus k, so that means the j component doesn't exist, so it's 1, 0, 1. So that's your equation for R2. And as a reminder, R1 that we just found was 2, 6, negative 1 plus lambda into 1 minus 2, 2. So these are the starting points, but these are the directions. So when they say find the angle between L1 and L2, what we're actually finding is the angle between the two directions. Now, there is a formula for that. Let's first label this direction. Let's call it something like D1, direction 1, and this is the direction of line 2. So the angle between the two lines is the angle between the two directions. And the formula for that is cosine theta equals the dot product of the two directions, that's the scalar product, divided by the product of the magnitudes of the two directions. And each of these we can find separately rather easily. So let's start with the dot product. So d1 dot d2, this is a scalar product, remember. So it would be 1, 0, 1, negative 2, 2, dot 1, 0, 1. Now remember, when you're finding the dot product, or the scalar product, you multiply the I components together, you multiply the j components together, and you multiply the k components together, then you add these together. So it's 1 times 1 plus negative 2 times 0 plus 2 times 1. So that will give you 2 plus 2 is 4, or no, 1 plus 2, sorry, is 3. So that's your numerator, d1 dot d2. Now we need to find the modulus of d1 and the modulus of d2. So the modulus of d1 is simply the square root of 1 squared plus negative 2 squared plus 2 squared. And that looks like it's going to be 4 plus 4 plus 1 under square root is 3. And the modulus of d2 is the square root of 1 squared plus 0 squared plus 1 squared, which is square root of 2. So now we can write our formula again. So cosine theta equals d1. So let's just take the formula from here. So it's d1 dot d2 over d1 d2. So the dot product was 3. So it's 3 divided by 3 times root 2, which is root 2 over 2. That's theta. So the acute angle, so that was cosine theta. So the acute angle theta would be the inverse cosine of that. So it's the inverse cosine of root 2 over 2, which is 45 degrees. The question didn't mention whether they wanted it in degrees or radians, but there we have the acute angle in degrees. The question goes on to say, find the position vector of the point C. The point C is the intersection point. It's where the two lines intersect. So if we look at these two lines, L1 and L2, they meet at this point C. They want the position vector of that point C. So that point C is where both of these lines are true. So R1 and R2, they are both true. So the x-coordinates of R1 matches the x-coordinates of R2, etc. So we can write this out like that, and we can say essentially that the x-coordinate of R1 should equal the x-coordinate of R2. Let's write that out. So 0 plus mu equals 2 plus lambda. That's your first equation. We can then also say that, well, the y-coordinate of the point C on the line R2 equals the y-coordinate of the point C on R1. So 0 plus 0 equals 6 minus 2 lambda. And finally, we can say that the z-coordinates are equal. So 0 plus mu equals minus 1 plus 2 lambda. So now we have 3 equations and 2 unknowns. It should be straightforward solving it. So if we look at the second equation, we can, because there's no mu there, just lambda, so we can find lambda easily. So from this, lambda equals 3. And then we can substitute that back into our first equation. So I'm going to take that 3 and substitute it into there. So we've got mu equals 2 plus 3 equals 5. And then we can check to see whether our answer is correct by substituting it in there as well and checking if it actually works. So check, is 5 equal to -1 plus 2 times 3? The answer is yes. So therefore we have the right set of numbers. So we can now find the coordinates of C using, let's say, R2, because it's easier, it's got the zeros in it. So we can say, if that's R2 and mu we found to be 5, so we simply substitute 5 instead of mu. So the coordinates of C will be 0, or if I just write it out as 5, 0, 5. So therefore, the coordinates of C would be 5, 0, 5. And the question is asking for the position vector. So when you're asked for a vector, it's not the coordinates they want, it's the actual vector. So that's how you would answer a question like that. You would equate the coefficients. So in general, when you have a question involving two vectors and you're looking for the angle, you always want to use this formula that involves the dot product or the scalar product of the two directions.